Hi and welcome back. This is Pankaj here. The last video that I made on the number system, that should have given you a insight into what are the different number systems that we have, and what's the difference between them, and so on and so forth. And in this video, I'm again going to be talking about basics. Okay, you might feel that I already know this and I don't need to actually go through this video. Well, there's no harm in actually going through these videos and looking at them. It's just going to be a refresher for you. Okay, and actually it might actually surprise you that this is something that you didn't know. Okay, so let's just pick it up and understand the video and look at few concepts. Okay, it's not going to take much time. It's just going to take 10 or 20 minutes maximum. Okay, so again, it's important for you to know these things to do questions in mathematics. Okay, many people miss these concepts, and that's exactly why they face difficulty when they are actually doing questions, okay, which are quite logical. Okay, because they forget or they don't actually remember these things. Okay, I'm just going to quickly start talking about it. Let's see. Okay, what are we going to learn in this particular video? We are going to be learning about polynomials. Okay, very quickly. I'm going to make it fast, as quick as possible. All right, now we have already learned about polynomials. We have the classification of polynomials. One is based on the number of terms, and the other classification is based on the degree of the equation. Okay, now what's the classification based on the number of terms? If the polynomial has one term, then we call it as a monomial, isn't it? So before I could use the word monomial, you had no idea what I'm talking about, right? Now suddenly it comes back to you. That's exactly what I'm talking about, right? So, and then we have two terms, then we call that as a binomial. And if it has three terms, we call that as a trinomial. And anything about three is simply called as a polynomial. Okay, so that's one kind of a classification of polynomials. The other classification is on the degree, based on the degree. Okay, so if the degree of the equation is a 1, we call that as a linear equation. Now, what does the word degree mean? What does it mean? A degree is the highest power of the variable. That is the degree. Highest power of the variable in the equation is the degree of an equation. So if it is a degree 1, it's a linear equation. If the degree is 2, then we call that as a quadratic equation. And if the degree is 3, we call that as a cubic equation. And if the degree is 4, we call it as a quartic. Okay, we call it as a quartic equation. Fine. So let's look at few examples of linear equation. 2x plus 3. Yeah? And then we have 7x plus 4. These are my linear equation. Now there are two things that I need to talk about. One is an equation, and then I have the expression. Expressions, and then I have the equations. Now what is an expression? All these are my expressions. Okay? These are my expressions. What's an equation? An equation is an expression equated to a value or another expression. This is my equation. Basically, it has an equal to sign in it. Okay, fine. So, an equation or an expression with the degree, the highest power as 1, is a linear expression or a linear equation. Okay. So, I can also have a 1 degree linear equation. 2x plus 3y is equal to 4. The degree of the term itself with the variables is 1, 1. So this is a linear. Let's look at a 2 variable degree 2 equation. 2xy plus x square plus y square plus 4x square, no, let's say 4x, yeah, that should be fine, equal to 5. Now, what is the power of the variables here? 1 plus 1, 2, 2, 2. You see the highest power is 2, and that's exactly why this is a quadratic equation in two variables. We all know the standard form of a quadratic equation, ax squared plus bx plus c in one variable. This is something that we have been learning, right? F of x is equal to. Okay, and a cubic equation is going to be something like this. Okay, all right. The standard form is going to be ax cubed plus bx squared plus cx plus d is equal to 0. That's the standard form of a cubic equation. Okay, all right, fine, great. So how is that going to help us? A linear equation will always generate a straight line on the graph. That's something that I guess you already know. If I have a graph, something like this, a linear equation will always generate a straight line. That's why it's called as a linear equation. And then a quadratic equation will always generate a parabola. Basically, the number of solutions to it will be a maximum of 2. Okay. We will look at what is the solution, what's the root of the equation, and so on and so forth in another video probably. And a cubic equation will have a maximum of 3 roots. It can have, a quadratic can have 0 roots, 1 roots, and 2 roots. A cubic can have 0. No, a cubic will have any one of them for sure. 1, either 2 or a 3 roots. A linear equation will have 1 root. What does it basically mean? That the line will cut the x-axis at one point only. A quadratic equation can cut the x-axis at one point, touch the x-axis at one point, something like this, or cut it at 2 different points, or do not cut it at all. And a cubic equation, the basic shape of a cubic equation will be something like this. It'll be like a wave. Okay, it's going to go like that. This is the x-axis and this being the y-axis. It will surely cut the x-axis at one point, and the other 2 points it may cut or may not cut, something like this. This cubic equation cuts it at 3 different points. Okay, so that is my linear equations, isn't it? Linear equations is the equation where the maximum power of x, or the variable or the degree of the equation, is 1. Now, what is a linear inequation? It is a linear expression, something like 2x plus 3, but it is not equated to a value. Rather, any one of the inequation has been used, like a less than, greater than, less than or equal to, greater than or equal to, not equal to, any one of these. Then what I get is a linear inequation. I can have linear inequations in one variable or in 2 variables also. 2x plus 3y is less than or equal to 5. This is a linear inequation in 2 variables. Now, what does this mean on the graph? We will be looking at that later. As of now, we will understand how to solve linear inequations and how to find a solution when the replacement set is being given to me. Okay. Now, let's look at a simple solution. Let's say I have an equation, something like 2x plus 4 is less than or equal to 0. So how do you solve this? You solve this exactly the same way how you solve a linear equation. There are certain situations where you need to actually, really think and change the inequality sign, but overall it's the same thing as how you solve an inequation. So 2x is less than or equal to minus 4, which means x is less than or equal to minus 4 by 2, which means x is less than or equal to minus 2. So what is the solution? The solution could be anything like a minus 3, minus 4, minus 5, isn't it? Well, I wouldn't say so, because my replacement set is not been given to me. What is a replacement set? A set from where I choose the solutions from. That is the replacement set. So if in case I'm saying the replacement set is natural numbers, set of natural numbers, then this does not have a solution, because all the numbers that I'm going to get is all negatives, and hence this solution set for this is going to be a null set if in case the replacement set was natural numbers. What if for the same question the replacement set was my whole numbers? Even then the solution is going to be a null set because whole number starts from a 0. What if my replacement set was let's say integers? Then my solution set is going to start from, okay, it's equal to -2, so it can go from dot -4 comma -3 comma -2, goes on till infinity. That's minus infinity. You understanding me? Okay. And what if my replacement set was set of real numbers? If my replacement set is a set of real numbers, I would not be able to write this in the roster form. This is a roster form, right, wherein I list all the elements belonging to that particular set. I cannot do that when the replacement set is real numbers, because what am I going to write? From 1 to 1.1, I can have 1000 decimals. 1.01, 1.001, right? 1.00001, and goes on. So you have an idea, between 1 to 1.1, I have lot of decimals, isn't it? So I will not be able to write that in the raster form. Instead, I can write that in the rule method. I can say x such that x is less than or equal to -2. Getting me? This is one way of writing the solution for real numbers. Or I can also say -infinity comma -2 square braces, and then this is small bracket. The square bracket actually tells that -2 is included in the solution. Basically, if you have a equal to, you will put a square bracket. This is another way of representing the solution set for real numbers, and this is specific to real numbers only. Okay, you will not do this for natural numbers or no, integers. When you write this, basically, it by default says it's connected to real numbers. Okay, so that is about my solution set and replacement set. Okay, so let's look at another example. Let's say solution set was something like x such that minus or 1 is less than or equal to x less than or equal to 2. So how do I write this in my real number bracket way? Because 1 is included, I'm going to put a square bracket, comma 2 is included, again a square bracket. Everything in between that is also included for the solution. So my solution set x belongs to this much. That is more than enough for me. Now let's look at something here. Let's say, for example, if you are trying to solve a linear inequation, these are things that you need to keep in your mind. Multiplication by a negative, multiplication by a negative, very, very important. What happens? Let's see. Well, 2 is greater than 1, isn't it? 2 is always greater than 1. Now when I multiply this with a negative sign, -2 is what I get on the left hand side and -1 on the right hand side. But isn't -2 lesser than -1? Yes, it is. And that's exactly why when you are multiplying inequality by a negative sign, your inequality sign should change. Another example, let's say for example, -1 is less than 1, isn't it? That's something that we already know. So now when I multiply by a negative, this is going to become a 1, and it has to be a greater than -1. I just multiplied by a negative sign. Got it? So be a bit careful about this. When you're multiplying by a negative sign, you need to change the inequality sign. Okay, and you also need to be careful when you're dividing, okay, or taking the reciprocal, basically. Reciprocals. What happens? You see, 2 is greater than 3. Now when I take the reciprocal, I get a 1/2, and this is 1/3. What is 1/2? It's 0.5, isn't it? But 1/3 is 0.33. It's a recurring decimal, so I put a dot on it to indicate that 3 is going to be repeating again and again. So 0.5 is obviously greater than 0.3, and so this. So when you're taking the reciprocal, be very careful. You have to change the inequality. If you can keep those two things in your mind, inequations is not going to be that tough. It's very, very easy. We will be looking at questions and then understand these things in detail. What I'm going to do is to pick up a few questions, very simple questions. Probably I'll do 3 questions. A maximum of 3 questions should be more than enough for us to understand these things. Let's say I wanted to represent this. -4 is less than x is less than 4. So the solution lies between -4 and 4, and x is belonging to real numbers. So that's my replacement set. I'm going to be picking up my solution from the real numbers. How do I write this? Because -4 is not included, I'll have to put a small bracket. -4, comma 4. Again a small bracket. Okay. And for example, if I need to write -5 is less than x is less than or equal to -1. How do I write this? -5, comma -1, and this bracket. Okay, these are very simple things that I'm explaining here, but believe me, they're going to play a major role. Okay, they're going to be playing a major role when you're actually doing questions based on this in your 11th, I think in your 12th also, actually, when you're doing a lot of chapters like application differentiation, you come across this. Okay, I see a very interesting question here, and a very important question actually. Let's see how to solve this. Great. So what I have here is 2x plus 1 divided by 7x minus 1. 2x plus 1 divided by 7x minus 1 is greater than 5. Is greater than 5. Now I need to solve this. Okay. Well, if it was an equation, I would have directly transposed this to the right hand side, isn't it? That is what I would have done. But in an inequation, I would not be able to do that. Why? Because I do not know if this is a negative number or if this is a positive number. If this is a negative number, then I need to change the inequality, isn't it? Because I'm multiplying by a negative. And if it is a positive number, then nothing happens, it just remains like that. Alright, so what am I talking about? Say, for example, 2 by -3 is less than 1, isn't it? So what happens when I transpose 3 to the other side? 2 minus 3 greater than, getting me? So I don't know, because x is a variable. I don't know what to do. Be careful about these things. How do you solve this? First, you transpose -5 from the right hand side to the left hand side. So it becomes -5 greater than 0. Now take an LCM for this. This is going to become 2x plus 1 minus 35, x plus 25 divided by 7x minus 5 is greater than 0. Okay, perfect. So this is basically going to be 26 minus 33x divided by 7x minus 5 greater than 0. So some people might say, oh, why don't I transpose it now? No, we don't. We still don't, because I do not know if this is negative or positive. So I cannot do that. But what I can certainly do is to multiply both sides by a positive number. That will not change the inequality. It will remain the same. Multiplication by a negative changes it. So what is the positive number that I'm going to be multiplying either side with? Divided by 7x minus 5 into 7x minus 5 whole square will be greater than into 7x minus 5 the whole square. Now this being positive, it's not going to have any effect on the inequality. But what is going to happen? This and this will get cancelled. So ideally I'll have 26 minus 33x into 7x minus 5 will be greater than 0. There you go. It's the same inequality which I solved in a different way altogether. Now, how do you solve this and how do you find a solution for these things? I'll explain that in the next coming video. Okay, but this is the basic thing that you do when you're solving the inequality with a fraction and an unknown in the denominator. You need to make sure that you do this. Most of the time when you actually go back to some of the textbook and try to understand these things, he would have jumped this step. He would have directly jumped from here to here. Okay, and confusing you even more. Okay, what is done? The step in between is this, which not many textbooks explain. Okay, that's okay. It's not a big deal. It's a small thing that we need to understand. Now that we know, we're clear. Okay, and we're going to be careful when we're doing these kind of questions. Okay, so with that being said, I'm going to stop this video. I know this is, I'm just stopping it very abruptly, but I'll have to stop this video for here, because in the next video I'll try and talk about few more concepts, and which is again, all these small videos are going to be helping me to solve linear programming. Okay, because when I start off linear programming, there are many things that I'm going to talk about. So I don't want you to feel like, okay, I don't know this, how do I do these things and stuff. I want you to be thorough with these concepts so that it's easier for you to understand when I teach you linear programming. Okay, with that being said, I'm going to stop the video here. Thank you for watching. Okay, please go ahead and subscribe for it, share it with your friends, ask them to view these videos. If you have any suggestions or any inputs that you have about the videos, please go ahead and post it onto the comment section. Thank you for watching. Goodbye.